بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Dear students of the General Secondary Certificate, welcome back to your program مدرسة على الهوا. Today inshallah this is the last session in our syllabus. It's Esters. Actually it's a very important topic. We passed over esters in chapter 2 and in carboxylic acids and in alcohols. Today it's a separate lesson for esters. Let's first welcome your guest and my guest, Mr. Muhammad Abdullah Riyad. Welcome back, Mr. Muhammad.
Welcome.
Dear students, before starting, don't forget to get your copybook, your pen, and let's follow our teacher. Let's start with the esters and remind our students how the esters be formed.
Okay. Esters, we said that ester formation or esterification, when we study lesson 2 about the reversible reaction between carboxylic acids and alcohol to form ester and water. Also, we study the ester formation when we deal with the properties of alcohols. We say that alcohol reacts with acid to form ester and water. Also, when we study the properties of acid. Now, let's do again say the reaction of ester formation or esterification, which is the reaction between carboxylic acids and alcohol. This reaction will be as follows: CH3 COOH, which is acetic acid. Acetic acid reacts with ethyl alcohol or ethanol, C2H5OH, ethyl alcohol. In order to prevent the reversible reaction and to let the reaction proceed in one direction, according to Le Chatelier, we can use H2SO4, strong sulfuric acid, to absorb water and prevent reversible reaction. Or we can use dry HCl. We know that the reaction occurs when OH from acid combine with H from alcohol to form water. The source of water, we say that from OH of acid and H of alcohol, plus CH3 COOC2H5, which is ethyl acetate ester. Ethyl acetate ester. How can we give a name to esters? In order to give the name of the esters, at first we take the alkyl of the acid, acetic acid. The alkyl will be acetate. Radical of the acetic acid, the salt of the acetic acid, acetate. And alkyl of the alcohol, ethyl. So it will be ethyl acetate. In order to give a name of the ester, we take the alkyl of the alcohol and the salt or the radical of the acid. Let's take some example according to the nomenclature of the esters. CH3 COOCH3. This is the ester. We know that the ester are COOR. The formula, general formula of ester, are COOR. When we make a separation between the two O, and then we add water to this compound, which contains CO, it takes OH to return to its original acid. CH3COOH, this is the acetic acid. We say that the radical of the acid, acetate. And we add H to the formula CH3OH, this is methyl alcohol. Methyl, the alkyl group is methyl. But this is called methyl acetate. Methyl acetate. Another example, C6H5COOCH3. we consider C6H5COOH as a benzoic acid. The radical is benzoate. And we said that CH3, we add H here to be methyl. This is called methyl benzoate ester. Methyl benzoate ester. Take care of we have this compound C6H5OCOCH3. The O is attached to benzene ring. This comes from phenol. يبقى this is phenyl, and CH3COOH will take OH to be the acid. This is acetate. يبقى it is called phenyl acetate. Phenyl acetate and methyl benzoate ester are isomers. Let's draw structure formula to give the difference between methyl benzoate COOCH3. Here's the bond C double bond O OCH3 attached to benzene ring. So it comes from benzoic acid. I said that C double bond O, we add OH to be benzoic acid. And this CH3O, we add H to form methyl. This is the formula of methyl benzoate ester. But phenyl, O is attached to benzene ring. O, C, double bond O, CH3. When we separate between the two O, C, double bond O, CH3. When O is attached to benzene ring, so we separate between the two parts to form. Here H, it is a phenol. Phenyl, and this acetate, this is phenyl acetate. Phenyl acetate. They have the same molecular formula, but they are different in structure formula. Let's take the properties of esters. We know that esters comes from the reaction between carboxylic acids and alcohol. So when we put ester with water, it is hydrolysis to form the acid and the alcohol. In presence of dilute acid, we call this acidic hydrolysis. Properties, acidic hydrolysis. This is about the chemical properties, and the physical properties of ester. We know that it has a good smell, a good taste, because the ester are found in fruits and in flowers. Ester, the first members are liquids, have good taste, good smell, but the big one, which has high molecular, they are waxy substance, solid and odorless. About the chemical properties, the ester, for example, CH3, COOC2H5, plus water, HOH, in presence of dilute acid, H positive. We call this acidic hydrolysis. As we said, we separate from L2O, and CH3CO takes OH to be acetic acid, CH3COOH. And C2H5O takes H to be C2H5OH ethyl alcohol. So ethyl acetate, hydrolysis in water to form acetic acid and ethyl alcohol. So what's about C6H5COOCH3? Also hydrolysis in water in presence of acid, dilute acids. it will be water plus water, it will be acid, C6H5COOH, benzoic acid, plus CH3OH, methanol or methyl alcohol. So it is called, I said, methyl benzoate ester. This is called acidic hydrolysis. What's about it? In presence of hydrolysis, in presence of alkali, we call it alkaline hydrolysis or saponification, because the soap is a type of ester. I will explain this when we explain the triglyceride esters or oil or fat. We know that oil and fat, as we studied, oil plus sodium hydroxide, oil or fat plus sodium hydroxide, it gives soap and glycerol. So let's write about the alkaline hydrolysis. Alkaline hydrolysis. يبقى hydrolysis of the ester in presence of alkalis such as sodium hydroxide or potassium hydroxide, for example. CH3, COO, C2H5, ethyl acetate ester, plus sodium hydroxide. It gives alcohol. C2H5O takes H to form C2H5OH, alcohol. And NaO combine with CH3CO to form the salt of the acid, CH3COONA, sodium acetate. So alkaline hydrolysis of ethyl acetate gives ethanol and sodium acetate. Also C6H5, COO, CH3, methyl benzoate, in presence of NaOH, alkaline hydrolysis, it gives alcohol and sodium salt. CH3O takes H to be CH3OH, methyl alcohol, plus C6H5COONA, sodium benzoate. This is called alkaline hydrolysis. We know that sodium salt of big acids will be the soap. I will explain this a few minutes later. Let's write about the third property, which is called ammonolysis. Ammonolysis. Reaction between ester and ammonia is called ammonolysis, and it gives acid amide. Ester plus ammonia, NH3, gives alcohol plus acid amide. Acid amide. This reaction is called ammonolysis. For example, CH3, COO, C2H5 plus ammonia, NH3. Also it gives alcohol. And these three properties of ester gives alcohol. Alcohol and acid, acidic hydrolysis. Alcohol and salt in presence of alkali, alkaline hydrolysis. Alcohol, also alcohol and acid amide, this is called ammonolysis. So it gives C2H5O takes 1H to be C2H5OH, ethyl alcohol or ethanol, plus CH3CONH2, acetamide, acid amide. Take care, only one O, CH3CONH2, acetamide. When we take this reaction using C6H5COOCH3, C6H5COOCH3, methyl benzoate, plus ammonia, ammonolysis, it gives methyl alcohol, CH3OH, plus C6H5CONH2 benzamide. So ammonolysis means that the reaction between ester and ammonia to gives alcohol and acid amide. This is the three equations for importance of the reaction of the ester. Let's try some questions about the importance of esters. Esters are used as flavors because they have good taste and good smell. They are used in flavors. For example, jasmine oil, it is a benzyl acetate. And another example, number 2, we use to form ester is used in making soap, what's called sabonification. Sabonification is the reaction between oil or fat plus sodium hydroxide. Oil or fat plus sodium hydroxide or potassium hydroxide to form soap plus glycerol. Oil or fat is a triglyceride ester. Triglyceride ester. Why? Because oil or fat comes from the reaction between ester and the 3 molecules of fatty acids. Glycerol, CH2OH, CHOH, CH2OH, plus 3 molecules. For example, R1COOH. This is an example of fatty acids. R2COOH, R3COOH. These radicals are one or two. The long may be short. It is saturated, may be unsaturated. Number 3, they are maybe similar or different. This is glycerol and these fatty acids. To form ester, we said that we take LH from alcohol and the OH from acids. We take care when we write equation about the ester formation. If the one of the alcohol or the acid contains the benzene ring, we use dry HCl. We don't use H2SO4 in ester formation. In presence of any one of the acid or alcohol contains benzene ring to avoid sulfonation. CH2O, CHO, CH2O, it forms CH2O, COR1, CHO, COR2, CH2O, COR3, plus 3 molecules of water. This compound is oil or fat. So we call the oil or fat triglyceride ester. Triglyceride ester because it comes from the reaction between glycerol and the 3 fatty acids. Triglyceride ester can react with sodium hydroxide or potassium hydroxide to form soap. Sabonification, we said that oil, which is CH2O, COR1, CHO, COR2, CH2O, COR3, plus sodium hydroxide, 3 molecules of sodium hydroxide or potassium hydroxide. It gives glycerol, CH2OH, CHOH, CH2OH. plus R1COONA plus R2COONA plus R3COONA. If the R are equal, it gives 3 molecules of soap, the sodium salt of these fatty acids. This is called saponification. If we use sodium hydroxide, it gives a hard soap. If we use potassium hydroxide, we get a soft soap or shaving cream. When we separate glycerol from soap, it is called hard methods. We can make this in our lab or in at home.
Actually, I have a question here.
Yes.
We have a give reason said that give reason saturated carboxylic monobasic acid, aliphatic acids are called fatty acids. After your explanation in this point, we can say that because they are found in esters in form of they are found in fats in form of esters.
Yes.
This is a correct answer.
Yes. Yes.
So
also, it is called triglyceride ester because it comes from the reaction between glycerol and 3 molecules of fatty acids.
So if the question come in the exam, dear students, explain monobasic aliphatic carboxylic acid saturated called fatty acids. Your answers, as our teacher said, will be because they are found in fats in form of esters. They are found in fats in form of esters. Thank you, Mr. Muhammad. Sorry for interruption.
Okay, welcome.
Okay. Now let's transfer to the other use of esters. As in medical, we said in flavors. We said as flavors. We said in saponification. Third one, we use it as in polyester. Then after that, the medical uses.
Okay.
Okay. Let's start with the polyester.
Polyester. We know that the reaction between acid and alcohol, it forms ester. When we use a special type of acids, which is called terphthallic acid, COOH, C double bond OH.
Actually, dear students, must remember that we have phthalic and terphthallic. Phthalic, the two carboxylic groups are in ortho positions to each other, while the terphthallic, the two carboxylic groups are in para position to each other. The one used in polyester is that they are in para position to each other, as our teacher drew now.
And also it is an aromatic dibasic acid. Aromatic due to the presence of benzene ring, dibasic because it contains 2 carboxylic group. Terphthallic acid react with ethylene glycol. Ethylene glycol, it is a dihydric alcohol. CH2OH, CH2OH, ethylene glycol. The reaction between terphthallic acid and the ethylene glycol, we remove water, H2O, OH from acid, and H from alcohol. And then we form ester. Benzene ring contains COOH, and here C double bond O, and this bond attached to O, CH2 bond CH2OH. It is a copolymer. This reaction, it is ester formation, and we can call it is a type of polymerization, condensation polymerization. Why? Because 2 different saturated molecules, 2 different acid and alcohol, different molecules, to form copolymer, and the small molecules, well, water, gives out or released. This condensation gives compound which is called copolymer. when the copolymer is attacked by acids and alcohol, this part COOH, it is a acidic or carboxylic group. So we can combine or joined with or attached by alcohol to form ester. And this H, this OH of the acid. And from the other side, the H of the alcohol can be attached to or attacked by acid. So this action can be continued until to give polyester. Polyester. So the reaction between acid and alcohol gives the ester, and when this reaction go on until we give large number of molecules attached together or combined together, it called polyester. From polyester, dacron. Dacron is inert substance. So we can use dacron in making artificial heart valves, and also instead of spoiled arteries, because it is an inert substance. This is about the polymerization of ester or polyester and the uses of polyester. Again, polyester, we get it from the reaction between terphthallic acid and ethylene glycol. It gives the copolymer. When we continue the condensation, this part contains OH of the carboxylic acid. It can be combined with or attached to or attacked by alcohol, and from the other side, OH of the alcohol can be attached by acids to continue the condensation to form at the end polyester. From the type of polyester, dacron, we said that the properties of dacron, it is inert, so we can use it in making artificial heart valves and instead of spoiled arteries. Last uses of the polyester.
Sorry for interruption. So after your explanation to this point, we can say that we have question here may come to the students, which is give reason. Dacron is used in treating the spoiled heart arteries or making heart valves. The answer, as our teacher said, because it is inert. It is inert. Inert means doesn't react with other substances. Sorry for interruption, because
the tissue of the bodies.
Doesn't react with the tissue of the bodies.
Yes.
Okay. Thanks. Sorry for interruption.
Welcome.
Okay.
The last one, the reaction, are used in medical cases or in making what's called marrow oil and aspirin. We use acid is called salicylic acid. Salicylic acid this is the structure formula of salicylic acid, COOH, OH. Salicylic acid. Salicylic acid has two function groups. Carboxylic group attached to benzene ring and hydroxyl group. So it can react as acid with alcohol to form ester and water. And also can react with alcohol to form ester and react with acid to form ester due to the presence of OH. Let's take the two reactions. At first, salicylic acid will react with methyl alcohol. Salicylic acid on benzene ring, COOH, and this OH. Will react with methyl alcohol or methanol. So the functional group of the acid, the OH from acid and the H from alcohol, it forms water, H2O. And then reaction occurs between the part of the acid, this is OH, C double bond O, O, CH3. C, double bond O, O, CH3, and OH. It is the ester. طيب we said that how to get the name of the ester. We take the alkyl of the alcohol, methyl, يبقى it is called methyl. And the radical of the acid, salicylic, يبقى radical is called salicylate. So it is called methyl salicylate ester. Methyl salicylate ester, or called marooch oil. Marooch oil. It is used in treatment of pains, comes from rheumatism, or we can call it the oil of green winter. So marooch oil or methyl salicylate ester comes from the reaction between salicylic acid and methyl alcohol, which is a ester formation. Here, when we use drying agent, we don't use conc H2SO4 due to the presence of benzene ring, so we use dry HCl. HCl dry. It is used as a dehydrating agent also. Number 2. This is about the reaction between alcohol and COOH, the group of acids. طب when we take the reaction between the OH of the salicylic acid, this is the salicylic acid, COOH, in OH, it is a hydroxyl group, so it can react with acid CH3COOH, acetic acid. Acetic acid, and this is salicylic acid. Also in presence of dry HCl. H is removed from hydroxyl group and OH from acid to form water, plus this is a part of the alcohol, O, CO, CH3, and here COOH is still added. It is called acetyl salicylic acid. Acetyl salicylic acid. Acetyl salicylic acid, because CH3CO is called acetyl group. Acetyl salicylic acid or aspirin. Aspirin. Aspirin is used in treatment of cold and headache. خلاص. Before forming aspirin, salicylic acid was used in treatment of headache and cold, but it causes bleeding of the stomach because it gives acids, and this effect of the salicylic acid. But aspirin also has effect in stomach, because aspirin is hydrolysis in water. It is a type of ester to form acids. Two acids. Let's to write this equation: aspirin plus water. COOH, OCOCH3 plus water, HOH. We said that is this hydrolysis. It gives salicylic acid, COOH, OH, and CH3CO O takes OH to be CH3COOH. يبقى it gives salicylic acid and acetic acid. It gives excitation to the stomach. It maybe causes ulcer. So doctors advise to use aspirin as a crushed powder, or dissolve in water, or mix it with alkali. Now, a new types of aspirin contains or mixed with aluminum hydroxide to be more safety, to neutralize the effect of the acid. This is about the aspirin and about the uses of ester. So we say that the importance of ester is used as a flavors due to the good smell and good taste of ester. Number 2, used in making saponification due to the reaction between the oil, which is a type of ester, plus sodium hydroxide. Number 3, used in making polymers such as polyester. We say that dacron is a type of polyester because it is inert, is used in making artificial heart valves or instead of spoiled arteries. Also, we can use it in medicine in making marrow oil or in making aspirin. This is the importance of polyester, importance of ester in general.
Actually, we have a point, we have a lot of questions about it, which is the uses of the acids in our life. Could we stress on this point? I know that we finished the syllabus and this point was explained in the carboxylic acids, but I need a stress on it for my students. Could we do it, please?
Okay, we can say, for example, formic acid. HCOOH. We know that a red ant or ant can excrete this acid for protection themselves from enemies. But we can use it in making dyes, in making insecticides, in making perfumes, in making plastics. Many uses of formic acid, formic acids. There also acetic acid, CH3COOH. Acetic acid, it has a pungent odor and the corrosive effect, but the acetam which we use is about 100%, only 400%. But it can be used with food, for example, in making insecticides, and dyes, in artificial silk. We use acetic acids. Okay, acetic acids can be form a crystal at 16 degrees Celsius. It can form a crystal similar to ice. So we called it glacial acetic acid. It may be give reason why we called acetic acid is a glacial acetic acid, because at 60 degrees Celsius it may be forms. It forms a crystal similar to ice. This is about acetic acids. Also about benzoic acid. Benzoic acid, we said that COOH. Benzoic acid. Benzoic acid slightly soluble in water, so we use the salts of benzoic acid, sodium benzoate or potassium benzoate, because these salts can dissolve easily in water. When we used 0.1% from sodium benzoate, can be used in preservation of food, because they prevent the growth of fungi or kill fungi. So we use it in preservation of food. This is about the benzoic acid and salt of benzoic acid. Also, about
Lactic acid. Yes, lactic acid or ascorbic acid we have.
Lactic acids, it is formed due to the presence of some bacteria in sugar of milk, and it causes construction of the muscles. It may be. This is about the lactic acid. Ascorbic acids or vitamin C.
What about the structure of lactic acid? Could we draw it CH3, then CHOH, then COOH?
CH2, CH3,
CHOH.
OH contains two function group,
Then
COOH contains acidic group and hydroxyl group. This is about the lactic acid, which is formed in our muscles. We know that the effect of construction when it occurs to some of us. About the ascorbic acid of vitamin C.
The structure is for illustration only,
Yes.
so the students just mention the uses of vitamin C or ascorbic acid.
Oh, ascorbic acid.
Actually, the lack of vitamin C causes a disease called escarpment, and also vitamin C found in lemon or in vegetables or in green pepper.
Yes.
The heat leads to the hydrolysis of vitamin C or air. Maybe it is left in air or heated, so it loses its importance or used in increasing the body immunity against cold. So it's not, if we are sick or having cold, we mustn't take hot lemon. It doesn't make anything to us because already vitamin C has been hydrolyzed.
Okay, vitamin C about 5 to 7% in lemon and about 1%
in orange.
Like as you said, we must take it fresh because it is hydrolysis by the effect of heat or in the air. This is about vitamin C.
Yes, let's transfer to citric acid.
Citric acid, okay.
Firstly, the structure, it's about 3 carbons attached to 3 COH group. 3 carbons.
3 carbons.
Attached to 3 COH groups.
It has 3 carboxylic,
groups,
COOH,
yes.
COOH, COOH.
And in the middle, OH group.
One hydrox group.
And the rest is hydrogen. Yes. By this way, we try to help our students to memorize the structure.
Yes, yes.
It's tribasic acid, found also in lemon, found in lemon, orange.
Okay.
Yes.
It is used to keep or retain the color and
the fruits, their
the
color.
smell of fruits because it decreases the pH value, so it causes killing of bacteria.
Yes, because it decreases the pH because become acidic medium and the bacteria doesn't work well in the acidic medium.
Okay.
Yes. Then we have salicylic acid.
Salicylic acid, yes. As we explained.
Actually, we have some scientific terms about these acids, such as we said aromatic acid have 2 different functional groups. It will be salicylic acid.
Yes.
If it is aliphatic, we have citric and lactic. Tribasic, aliphatic, citric. Monobasic, aliphatic, and has 2 different functional groups. Lactic.
Salicylic acid. Okay. Lactic acid has also.
And salicylic acid, we said it causes bleeding. It was taken to treat cold and headache, but it causes bleeding, so we stop use it. Okay. And we take it in another form, mix it with aluminium hydroxide to minimize the
effect of aspirin.
The
effect of acid, effect of aspirin. Amino acids.
Yes.
Amino acids.
Actually, our students in the biological section or the bio section know well that the amino acids are the monomers of the proteins, because the proteins are polymer. When they are digested in our bodies, they convert into amino acids.
Here we have the acid contains COOH and amino group. For example, this is acid. Contains carboxylic group and NH2 amino group. There are many amino acids in nature. but in living organism there are 20 types of amino acid. These amino acids from the type alpha amino acids. And what's meant by alpha amino acid? Alpha amino acids mean that the amine group is attached to the carbon alpha. Carbon alpha is the second carbon in the chain, or the carbon comes after COOH. This carbon is called alpha carbon. All type of 20 amino acids in food are from the type amino alpha. We know that there are 10 essential amino acids and 10 non-essential. Non-essential because the body can form them. But all amino acids are very important for a human being. But 10 essential amino acids are found in protein in animals, but in plants less than 1 or 2 of amino acids. Amino acid, for example, when we take acetic acid, CH3COOH, and we replaces one of hydrogen by NH2 amino group, this is called amino acid or glycine or amino, due to the presence of amine group, amino acetic acid. This is example of glycine. When we increase, it may be forming alanine. This is another type of amino acid. Amino acid, by condensation of amino acid, it is the building unit of protein. Amino acid and amino acid gives peptides by peptide bond, and peptide gives peptone until it gives protein. So protein is a polymer of amino acids. Protein is a polymer of amino acids. It is made of long form. For example, we get insulin.
Yes,
it is very
insulin.
important. It is made of, I think, 15 number of...
it's made of 51 molecules and
51 molecules of
51 molecules, 16
type
type
of
amino
acid. And the molecular weight about 6,000 unit. It is a big molecules. So it is a type of protein.
Actually, and some enzymes reach to 1 million. Their mass reach to 1 million.
Yes. This is about the importance
of acids in our life. Actually, I need to answer some of the questions or convergence happen between carboxylic acids and esters. Okay. Firstly, let's say that, for example, starting from ethene, how can you obtain acetic acid? Starting from ethene, this question is very important for the students, how to obtain. It's confusing for the students, and we need to learn them how to pass this kind of question.
Convert ethene to
acetic acid.
Acetic acid, we can get acetic acid by many methods. I said that. It may be by oxidation of aldehyde or oxidation of alcohol. So we can easily convert C2H4 to alcohol by adding water, catalytic hydration, in presence of sulfuric acid, H2SO4, at 110 degrees Celsius, to form ethanol, C2H5OH. Then ethanol can be oxidized by presence of Wenger bacteria or presence of KMNO4 acidified. This is diagram to know how I can take the steps in order to to convert ethene into acetic acid. But we must write the complete balanced equation. Take care. This is diagram for you in order to know how I make this set, how I process to get this equation. Number 1, C2H4 plus water, H2SO4, conditions very important, 110 degrees Celsius to form C2H5OH. ethanol. Then ethanol C2H5OH plus oxygen O2 in presence of K2CR2O7 acidified or KMnO4 acidified, it gives CH3COOH plus water. This is about how to convert ethene into acetic acid. Another?
Yes. Suppose we need to continue after obtaining the acetic acid. We need to continue to obtain an ester. And
Okay.
starting from ethene, how can you obtain ester?
We get acetic acid. Then acetic acid, CH3COOH, react with alcohol. It may be about of the ester, what we know, you need from the type of ester. Which ester you need?
Suppose we need ethyl ethanoate ester.
Ethyl. يبقى we take C2H5OH,
Ethyl
ethyl alcohol, in presence of, I said, H2SO4, conc to prevent the reversible reaction. It gives CH3COO, C2H5 plus H2O, ethyl ethanoate or ethyl acetate ester.
From the other conversions that we have, let's say starting from benzene, how can you obtain benzoic acid and vice versa?
Okay. From benzene,
Actually,
we want to get
benzoic acid. These questions are some sort of bonding between all the topics of the
yes, benzoic acid
and vice versa.
and vice versa. In order to convert benzene to benzoic acid, benzene at first we convert it into toluene by CH3Cl Friedel-Crafts or alkylation in presence of anhydrous aluminum chloride to give toluene, CH3 plus HCl. And then by oxidation of toluene, CH3, 3 oxygen, in presence of vanadium pentoxide and 400 degrees Celsius, it gives benzoic acid and water.
So we need 2 toluene molecules. Yes.
Plus water.
2 toluene molecules and 2 benzoic acid produced.
And can write 3 and between 2 brackets oxygen to be more active. Or when I take O2, I must put 2 here, and 3 here, and 2 for the acid, also for the water.
The last one is the vice versa.
The vice versa, how to convert benzoic acid, COOH, can react with sodium or sodium hydroxide or sodium oxide, neutralization, to form sodium benzoate, COONA plus water. And we know that by dry distillation of sodium benzoate, COONA, in presence of soda lime, sodium hydroxide, and the calcium oxide at the arrow and heat, this is called dry distillation, we get benzene and sodium carbonate, Na2CO, as we get methane.
Thank you, Mr. Muhammad. The time has passed with you very quickly.
Thank you.
Thank you, dear students, for being with us. We'll wait for you for the next session. Assalamu alaikum wa rahmatullahi wa barakatuh.